Millions of years ago, the Earth's continents were initially one big supercontinent, surrounded by an immensely vast ocean. However, the supercontinent gradually broke up and scattered to become the continents we see today. Right now, another split seems to be occurring within the African continent, captivating scientists alike. But what exactly is happening? Are we in any danger? Or is the world coming to an end, as most suggest? Let's find out. Lately, a colossal crack in the Kenya Rift Valley caused a stir in the global media. Many reputable experts and scientists have actively worked to understand the cause of this odd and mysterious fissure, which seems to have emerged overnight. Though it might sound frightening to many, this occurrence is not new, but it is unusual. In southwest Kenya, an enormous fracture that spans several kilometers developed out of nowhere. The Nairobi-Narok roadway recently collapsed due to the crack, which is still expanding. The East African Rift's tectonic activity was linked with the crack's early stages. Gillies formed by erosion are one theory for why this happened. Questions remain, though, about why the split was created, where it did, and whether it has any relevance to the East African Rift. The Earth's outer layer is like a jigsaw puzzle, made up of big pieces called tectonic plates. These plates are not stuck in one place, but actually move around on a soft layer of rock beneath them, called the asthenosphere. Scientists are still trying to understand why the plates move, but they believe it has something to do with the forces acting on the edges of the plates and the currents in the asthenosphere. Sometimes, these forces become very strong, and they can cause the plates to not only move, but also crack or break apart. When this happens, it creates a gap called a rift. Over time, this rift can become a new boundary between two plates. Right now, one place where this process is occurring is known as the East African Rift System, EARS. In the East African Rift System, the Earth's crust is pulling apart, creating a rift or a gap. This rift stretches across several countries in Eastern Africa. It is an example of how tectonic plates can change and reshape the Earth's surface. The East African Rift System is still evolving, and scientists are studying it to learn more about how our planet changes over time. The East African Rift Valley is a long crack in the Earth's surface that stretches over 3,000 kilometers from the Gulf of Aden to Zimbabwe. It divides the African plate into two parts, the Somali and Nubian African plates. There has been recent activity along the eastern branch of the Rift Valley, which runs through Ethiopia, Kenya, and Tanzania. This activity became noticeable when a big crack suddenly appeared in southwestern Kenya. A big crack in the ground, about 50 feet deep and 66 feet wide, might have happened because of a larger splitting of the Earth's surface. It's possible that heavy rains in the area made the crack visible and caused it to suddenly form. This splitting can cause things like volcanoes, earthquakes, and cracks in the ground to appear. But what actually causes this splitting? The splitting, called rifting, happens when the Earth's outer layer, called the lithosphere, gets stretched horizontally and becomes thinner. Eventually, it breaks apart, creating a valley. Volcanoes and earthquakes are signs of this process happening on the surface along the valley. In some cases, the splitting can lead to the creation of a new ocean. The South Atlantic Ocean, which formed about 138 million years ago, when South America and Africa separated, is an example of this. To cause this splitting, there needs to be strong forces that pull the lithosphere apart. The East African Rift is an example of an active rift where the movement of the Earth's mantle below is causing these forces. The lithosphere under this rift is getting lifted up by a big column of hot material from the Earth's interior. This makes the lithosphere weaker and eventually breaks it apart along faults. Geophysical studies have shown evidence of this unusual hot mantle plume, commonly referred to as the African superswell. This superplume has been widely used to explain the anomalously high topography of the southern and eastern African plateaus. Next to that, the superplume is widely accepted as a source of the pull-apart forces causing the formation of the Rift Valley. The topography of rifts is particularly distinctive, consisting of several depressions bounded by faults and surrounded by higher ground. From space, it is possible to discern the East African system as a collection of aligned rift valleys, divided from one another by sizable bounding faults. Not all of these cracks develop simultaneously, but rather in a series that moves southward into Zimbabwe at a mean rate of between 2.5 and 5 centimeters per year, beginning in the Afar region of northern Ethiopia about 30 million years ago. Otherwise, rifting is mostly undetectable to us. The formation of new faults, fissures, and cracks, as well as renewed movement along old faults as the Nubian and Somali plates continue to move apart, can result in earthquakes. However, in East Africa, the majority of this seismicity is of very moderate size and is dispersed across a large area. Over the Rift Valley, volcanism is an additional surface indication of the ongoing process of continental breakup and the proximity of hot molten asthenosphere to the surface. The East African Rift is remarkable because it allows us to see many rifting stages along its length. The rift is young in the south, where extension rates are low, and faulting is widespread. There are few earthquakes and volcanoes. However, the Rift Valley bottom is entirely covered with volcanic rocks. As it approaches the Afar region, also known as Region 2, it shows that the lithosphere has nearly completely broken apart in this region due to the lithosphere being fed. When this occurs, magma will start to solidify, and the gap left by the broken-up plates creates a new ocean. Over millions of years, a tiny shallow sea will start to separate the eastern edge of Africa from the rest of the continent. It will eventually develop a substantial island in the Indian Ocean. As the rifting progresses, there is a good chance that this island will include portions of Ethiopia, Somalia, Kenya, and Tanzania. Scientists have been aware of the rifting in Africa for a while, but the exact cause has been difficult to determine. The Earth is an ever-changing planet, even though in some respects, change might be almost unnoticeable to us. Plate tectonics, or the East African rifting, is a good example of this. The rifting is a very slow process, but most of the time, it goes about splitting Africa without anybody even noticing. While this sounds frightening, the timeline for that is extremely long-term. Thankfully, scientists estimate that the rifting process in Africa will take tens of millions of years as the crust begins to thin and sink, and a small seaway begins to intrude the rift zone and eventually form a huge ocean, separating the continent into two. So, if you're already in shock, hold your breath, since none of us or our children's generation will be around to experience the impressive occurrence. So, we are not sure what will happen in the Afar area in terms of tectonics. We don't know if it will turn into an oceanic spreading center, if an ocean basin will form between the Somali and Nubian plates, or how spreading will happen in the Red Sea and the Gulf of Aden. These are all things we haven't figured out yet. According to one model, the Red Sea and the Gulf of Aden won't exist anymore in 50 million years. This is because the Somali and Nubian plates will collide with Arabia and join together with the three plates that exist today. Currently, the volcano eruption at Erta Ale is still happening. Based on research, the process is happening at the East Pacific Rise's mid-ocean ridge, and the volcano's magmatic plumbing are closely related to continental processes. We still don't know if this similarity indicates what will happen in the future. Scientists studying volcanic activity in the region have identified a significant geological phenomenon known as a rift-to-ridge transition. The continuous eruption in Erta Ale, a volcano located in the intersection of the African, Somali, and Arabian tectonic plates between Djibouti and Eritrea, suggests that a new ocean basin and its associated mid-ocean ridge will be formed over time. This Y-shaped intersection of tectonic plates is a focal point for researchers who believe that it is the starting point for the creation of a new ocean. However, the process of ocean formation is an extremely slow one, spanning tens of millions of years. As a result, scientists are unable to predict with certainty the fate of the two landmasses and whether or not a new ocean will indeed emerge. The ongoing eruption of Erta Ale provides valuable insights into the geological processes at work in this region. By studying volcanic activity and the resulting changes in the landscape, scientists hope to gain a better understanding of how new oceans are formed. This research has the potential to contribute significantly to our knowledge of plate tectonics and the evolution of Earth's geology. What do you think about this fascinating topic? Let us know in the comments. If you like this video, don't forget to subscribe, like, and share it with friends. Want more excitement? Simply click the next video on your screen. Thanks for watching.